So in this process here, it said, the question says, if 0.465 liters of water are in a glass, what is the volume of water in milliliters? So we're not changing volumes, we're just changing how we describe that volume. We're translating it from milliliters, excuse me, from liters into milliliters. So our given is 0.465 liters, right? That's what we've been given. What's unknown is how much that is in milliliters. What is my statement of equality going to be? Something equals something. That's going to help us move from one thing to another thing. I need something, right? My Rosetta Stone here, my ability to translate between one and the other means I've got to have some relationship between liters and milliliters. Give me a true statement that relates liters and milliliters. Oh, these lights are loud. Can't hear. Yes, sir. You could say that 0.001 liters is equal to 1 milliliter. You said 0.001, so I was trying to make it as correct as I could. 1 liter equals. It's 1,000. See? Oh, by the way, this is the same thing. You just said the same thing twice and slightly differently. That 0.001 liters is equal to 1 milliliter, and that 1 liter is equal to 1,000 milliliters. This is the same thing. See? Because if I divide this by 1,000 and I divide this by 1,000, it'll be same thing. Okay? So we could write either one of these statements of equality. If you remember that 1 milliliter is equal to 0.001 liters, or if you remember that 1 liter is equal to 1,000 milliliters, I can use either one of them and still get the same answer. Let's take a look at that. Matter of fact, we'll do that since that's on the table. These are we have two statements of equality. They're both true. So let's write down our given, 0.465 liters times a unit conversion factor. Let's start with this one. We'll call it, this will be A, this will be B. Let's use A first. I'm converting from liters, and I need to get my answer in milliliters. I need a statement of equality that'll give me liters and milliliters, and let's use the first one here. 0.001 liters is equal to 1 milliliter. I see that liters cancels liters, leaving me with milliliters, and that's what I'm looking for. So again, I'm confident my setup is correct. Now actually doing the math. We have 0.465 divided by 0.001. When I actually do the math, I'm dividing by times 10 to the negative third. When I divide by that, it's going to move the decimal over 3 places to the right, and it gives me 465 milliliters. I could use this second statement of equality, since they're both true, and write it this way. 0.465 liters times, I need milliliters over liters again, because I need something that's going to give me milliliters. The second one says 1 liter is equal to 1,000 milliliters. Liters cancels liters, leaving me milliliters, which is what I'm looking for. Confident my setup is correct. Do the math. 0.465 times 1,000, moving the decimal place 3 places to the right, 1, 2, 3, and the answer is 465 milliliters. 2 paths to the same answer because your statement of equality is true in both cases. So which one of these is right? Yes, they're both right. But some process is going to get you from liters to milliliters using something that's true that relates the two. You could have taken it from liters to centiliters to decaliters to milliliters. But why would you? You don't need to. We'll actually cover some of that as we do more complex conversions using indirect conversions today. So That's why I said, okay, given statement of equality, produce a conversion factor, and then do the math. Remember, the math always includes both the number, which I'll refer to as the coefficient, and the units. You could say 465 what? 465 ducks? No, 465 milliliters. Why does it matter? Because we were converting from liters to milliliters. I'm not sure what unit you're trying to present. Make sure it's 465 milliliters, because that's what we were asked for in the problem. If you find yourself getting to the end and you have an answer, in this case we solved for milliliters, were we actually looking for milliliters? Yes, we were. Okay, we did it correctly. If we end up with something here like decaliters or kiloliters, say, wait a minute, I've got kiloliters. This might be true, but is it what I was asked for? No. Okay, now I need to convert somehow from this to kiloliters and do another conversion. Are we good? Guys, a little. Even if you didn't, even if this is the process you used, does it at least make sense to you? Does the logic of it make sense? That's why I encourage you to get into the on your owns, practice it. Even if you've done the on your own before, if you're not confident, take a clean piece of paper, do it again. Do the same problem 2-3 times. Show yourself that you can lay out the process, that you can get the right answer in the back that's included in your book before you move on. And I do encourage a couple of you to check your syllabus. It did say in there that today's quiz would be based on your own's 1, 2, and 3, or example 1. So there were only really 4 questions that it would look like. And doing the actual problem is a lot like looking at it, right? It's like an identical twin. We did the same problem. So I feel free to use exact problems from the book. And that just communicates back to me again, are you actually in the book? Are you actually doing the reading and doing the assignments? Because I'm not collecting on your own, I'm not grading them, but they're the basis for your quizzes. We're picking up today on page 12, conversion between unit systems. I mentioned last time we were together that converting between unit systems is just like what we've been doing already. Converting from the English system to the metric system, all you're going to need is a statement of equality that's going to convert you from one unit to the other. And on table 1.3 on page 12, they give us 3 different measurement types, distance, mass, and volume, and they give us a unit conversion factor, or excuse me, a statement of equality that we can use to produce our conversion factors. Matter of fact, the concept is so similar, they jump right into example 1.2, saying that the length of a tabletop is measured in 37.8 inches. 37.8 inches. What is the length in centimeters? So again, talking about word problems, hopefully you'll begin to see very quickly how to take the word problem and convert it into a math problem. A tabletop is measured in 37.8 inches. What is its length in centimeters? So, given equality, what is my statement of equality going to look like here? We're going to get it straight from table 1.3. We need something that relates inches and centimeters. You can see that the very top one, the one on distance, page 12, table 1.3. Distance, 1 inch. The 1 inch equals 2.54 centimeters. So that's a true statement. And I can use that true statement to produce a conversion factor. So let's go ahead and do that, the conversion factor. Given 37.8 inches, and I need something that's going to take me to centimeters. So when I look at creating my conversion factor, what units need to be in the denominator, in the bottom? The same units that are in my given. So since I'm given inches, I need to convert using inches in the denominator so that inches will cancel inches. I want to end with centimeters. So centimeters has to be in the numerator of my conversion factor. If it's not, we may need to do a 2-step or a 3-step conversion, and we'll do one of those soon. But for right now, we can do a 1-step conversion because I need centimeters in the numerator, inches in the denominator. Then I look to find my statement of equality that has inches and centimeters. So 1 inch is equal to 2.54 centimeters. I might add another step in here. I didn't use it before, but let's say check my units, because I do that every time as well. Check units. So given equality conversion, check units. Checking my units. Inches, and in the book, I don't always do this because, frankly, it's kind of like, it's obvious to me, but it may not be to you. Remember that when we have anything, we can always make a fraction out of it by placing it over 1. If that helps you to remember how to do the math. Because in multiplying fractions, remember, you multiply the numerator times the numerator produces the numerator, and the denominator times the denominator produces the denominator. So by placing that over 1, it might help you visually to keep it straight. So 37.8 inches, we're checking the units. We've got inches, cancels inches. We're left with centimeters, and centimeters is what we're looking for, so I'm confident my setup is right. Now we do the math. And I'll cheat and look into the book, and they say that it's 96.012. 96.012 centimeters. Now, in the problem we just did as a quiz, it was a multiple of 10, right? 1 to 1,000 relationship kind of a thing. Here, it's not 1 to 1,000, a nice base 10 relationship. Here, it's a 1 to 2.54 relationship. But the math still works out the same. A given quality creates a conversion factor, check my units, do the math. I didn't put the 1, but it's 1 times 1 is 1. And you were learning chemistry that 1s are always implied. You don't have to write the 1. And you would know in math that 96.021 divided by 1 is the same as 96.021. Questions on that? Let's do 1-4 on your own. Start ahead of me and I'll catch up to you. Converting from kilograms to slugs. If you've already done the reading and done the problem, that's great. If you want to check it, make sure you did it correctly. You should have been able to do that in the book as well. Even if you've already done it, though, if you don't have it in front of you, go ahead and try it again. Just lay it out real quickly. Okay. So we're given that 8.45 slugs is equal to some amount of kilograms. Coming up with our statement of equality. What is our statement of equality going to be? So it's 14.59, okay? So 1 slug is equal to 14.59 kilograms. Statement of equality came straight from the chart, or the table there in 1.3. So 1 slug is 14.59 kilograms. We've got the given, we've got the equality. We're going to produce a conversion factor because we have 8.465 slugs times something that's going to produce an answer in kilograms. I have slugs in the numerator. I'll put it all over 1 for now. Again, you don't have to do that, but if it helps, do it. 8.465 slugs. We need to have slugs in the denominator of our conversion factor. We need to have kilograms in the numerator of our conversion factor in order to end with kilograms. I look to my statement of equality and plug in what I have to create the conversion factor. That 1 slug is equal to 14.59 kilograms. And in so doing then, after I create the conversion factor, I check my units. Slugs cancels slugs, left with kilograms, and that's what I want. So I have a high confidence that I've set it up correctly. And then we do the math. Don't have the math in front of me, so I'm going to not cheat. I'm going to look back to the answer key and assume that they did it right, which they don't always. Remember that. They don't always do the on your owns correctly. But they're indicating that it's going to be 123.5 kilograms. Let's look at that and see if that's a reasonable answer. If I look at 8.465, what is that approximately? We could say 8 or 9, right? Let's say it's 8. 8. And 14.59, that's approximately 15. So what's 8 times 15? 120. 8 times 15 would be 120. Is it about 120? Is that my answer? It's about 120. So I know it's a reasonable answer. Okay? Since I didn't do the math myself, I can see that 123.5 is reasonable if we do 8 times 15. In this case, too, just as a technique, yeah, this is technically just below halfway, and this is technically just above halfway. But even if this were exactly halfway, if I round this one down, we tend to round that one up just so they kind of offset each other as I approximate the answer. So I'm willing to accept 123.5. If the book gets it wrong, it's normally because they do something inverted, and it's off by like a factor of 100. It's not off by a couple. Now, this is a direct relationship. Okay, it's a one-step direct relationship. I can go from slugs directly to kilograms. But the next section here, talking about more complex conversions on page 13, is moving into this idea of indirect relationships. And we did one of these already, but it was way back in the beginning of class, like 2 days ago. Okay? We did an indirect relationship, and we're going to do another one here. The example in the book on page 13 takes us from centiliters to kiloliters. From centiliters to kiloliters. Now, let's just think about this for a moment. I'm going to write the units up here. We're going to go from centiliters to kiloliters. Does anyone in here right now, off the top of their head, know a statement of equality that relates centiliters to kiloliters? You probably don't. Somebody might, but it's not intuitive. But it's great because this is part of the metric system, and so we can determine statements of equality using the prefixes, right? We've got centiliters and we've got kiloliters. Now, what is the statement for a centa? Whatever it is. In this case, we'll use liters just because, it makes sense. One of two possibilities. Which way do we want to orient it here? 0.01 what? 0.01 liters? Liters, okay, equals 0.01 liters is equal to 1 centiliter, right? Okay. 1 centiliter is equal to 0.1 liters. Another way to write that would be that 1 liter, this is the way I tend to memorize it, 1 liter is equal to 100 centiliters. Okay? So using this, one of these statements of equalities, what would my units look like? I can go from, in this case, I can go from centiliters to what using one of these? I can go from centiliters to liters, right? I can go from centiliters to liters, or I can go from liters to centiliters, or, but they're both true. So one is translating, these are both translating, rather, from centiliters to liters and back and forth, between liters and centiliters, back and forth. So that will take me from centiliters to liters. Is that where I want to end up? No, I'm going from centiliters to kiloliters. That unit conversion will only take me from centiliters to liters. Now where do I need to go? From liters to kiloliters, right? So can I have a statement of equality for liters to kiloliters then? Okay? But the way... No, wait. I usually remember this one as the other way. 1 kiloliter is equal to 1,000 liters. Right? A kiloliter is 1,000 of them. A centiliter is a 1/100th of one. Difference between 100 and 100th. And 1,000 and 1,000th. Did I get it wrong? I see a couple people that are looking at it like I got it backwards, but I think I'm right. I'm not always right. I'm not omniscient. I'm not perfect in here, okay? You guys are going to find out I make math errors and I make concept errors at times too. But is this right? Do I have consensus that this is right? Or do you think am I wrong? A liter is 100 centiliters. Is a meter 100 centimeters? So a liter is 100 centiliters, right? And a kilometer is 1,000 meters. In the same way, a kiloliter is 1,000 liters. So by using one of these statements of equality, I can go from centiliters to liters using one of those, one of those two from that set. And then I can go from liters to kiloliters using one of the statements of equality found in B. So this is why it's called an indirect relationship. I can't get there directly. I've got to kind of go around the corner to get there. I've got to go from centiliters to liters and then from liters to kiloliters. In the case here, they said we're going from 4,523 centiliters, and I know now that we need two different conversion factors to end up in units of kiloliters. Okay. So, if we didn't recognize that we needed two conversion factors, we thought we only needed one, what would ideally I be able to put in here? What are my units for my first conversion factor? Well, centiliters would be on the bottom, and if we could, ideally we would have kiloliters on the top. But in order to do that, we would need to have a statement of equality that told us how kiloliters and centiliters related to one another, and we don't have that. So I can't do that. The best I can do now is go back to liters. And that's typically going to be the case. You're going to go back to the base unit. What is the base unit? So here, for volume, the base unit is the liter. So I can go to a secondary unit to the base unit, and then from the base unit on to another secondary unit. So I need something that's going to relate centiliters to centiliters, or excuse me, centiliters to liters. With this setup, I know centiliters is going to cancel centiliters, and I'm left with liters. I look to a statement of equality about liters and centiliters, and I'm going to use 1 liter is 100 centiliters. Okay. But this will get me an answer that's in liters. That's not what I want. I want an answer that's in kiloliters. So I need another conversion factor. That second conversion factor is going to have liters in the denominator because I've got liters remaining in the numerator. And in the numerator here, it wants to end with the same units I'm looking for. So I'm looking for kiloliters. Ideally, I have a statement of equality that relates liters and kiloliters. And do I have one? Sure do. I've got two to pick from right here. And either one of them will give me an accurate, true conversion factor. So looking at that, liters and kiloliters, I see that 1 kiloliter is equal to 1,000 liters. Now I have liters, canceling liters. The only units I have in the numerator left that aren't canceled out are kiloliters, and that's what I'm looking for. Do I have any units remaining in the denominator? Nope, they've all been canceled out. So I have no units for my denominator, which means my only units are going to be my numerator my numerator units. Then I do the math. In this case, it's 4,523 divided by 100,000. Right? 100 times 1,000 is 100,000. Now, for 100,000, when I divide by that, I can do it, since it's base 10, the advantage of the metric system, is I can do this simply by sliding the decimal point, right? Let's look at it here. We've got 4,523. The implied decimal is right there. Everybody with me? That's the implied decimal right there. I'm not going to leave that 0 there. I'm going to take it off because I don't want to show an inappropriate amount of precision. But 4,523 and the implied decimal point. Now, I'm going to move the decimal point because I'm dividing by 100,000. First of all, how many places am I going to move the decimal? 5. How many zeros are there? There's 5 zeros. So I'm going to move the decimal 5 places. Am I going to move it to make this number bigger or smaller? So we need to move the decimal to the left. 5 places to the left. 1, 2, 3, 4. I need another 0 for as a placeholder and a leading 0 in the front. So my answer here is 0.04523 kiloliters. That's what the text shows on page 13. Okay? So all I'm looking at here as I wrote this process down is my units. Going from centiliters, I want to go to kiloliters, but I may not know how to get there. But I know how to get from any unit to its base unit in the metric system. So I can go from centiliters to liters, and then from liters to kiloliters. It could be meters. I could go from centimeters to meters, and then from meters to kilometers. It could be grams. Centigrams to grams, grams to kilograms. Guess what? The conversion factors would all be the same because these are standard conversions between the base unit and the prefixed unit. Let's go ahead then. On page 14, you can see another example. The same thing. In this case, they're going from kilograms to milligrams. And we're not going to do the whole problem, but let's look at just the units, going from the starting units to the ending units. And let's think about what our conversion factors would look like. You can see it on the page. I realize that, but let's just think through it for a minute. We're starting with kilograms. We're trying to end in milligrams. Okay? Do you know a conversion factor right now that takes you from kilograms directly to milligrams? Most of us don't. We don't think like that. But we do know in metric that we can always use the prefixes to figure out how to go from the unit to the base unit, and then from the base unit to the ending unit. So what would be our flow in terms of our units here? We're starting with kilograms. I'm probably going to find to relate that to what? To grams, my base unit. Then once I'm in the base unit, I need another statement of equality that'll become a conversion factor to take me into my desired units. So I'm going to go from kilograms to grams, from grams to milligrams. And because it's a kilo, I'm not going to write down grams, just because it's a kilo, I know that 1,000 of my base unit is equal to 1 kilo of whatever my base unit is. And I know that 1,000 milli of whatever my base unit is equal to 1 of whatever my base unit is. I'm just using the line for base unit. Because it could be, again, it could be meters, liters, grams. That's always going to be the same because it's the prefixes. Kilo means 1,000 of them, and milli means 1/1000th of them. So I would expect here we'd have kilograms times kilograms relating to grams times grams relating to milligrams to get an answer in milligrams. This will all be over 1. Kilograms cancels kilograms, grams cancels grams, leaving milligrams, which is what I'm looking for. Then whatever the number was here, plus my conversion factors, let's do the math. Let's start to take a look at 1/6 on your own at the bottom of page 14. Let's talk through the setup first, and then I'll have you do it, and then we'll walk through it on the board. 1.6 on your own, page 14, says a balloon is blown up so that its volume is 1,500 milliliters. What is its volume in kiloliters? Okay? So right now, look at just at the units. Just at the units. I'm starting with milliliters, and I want to go to kiloliters. Do you know with confidence that you have a conversion factor, a statement of equality, that'll take you directly from milliliters to kiloliters? No. So, lacking that, what are we going to do? It's metric, right? So let's go from the given unit to the base unit, and then from the base unit to the desired unit. So I need one statement of equality that relates milliliters and liters. I need another statement of equality that relates kiloliters and liters to create unit conversion factors to move from my known to my desired. Let's go ahead and start setting that up. Remember that your table with the prefixes on it are on table 1, 2 on page 8. That's going to get you from what the prefixes mean if you haven't memorized them yet. So put the reminder on the board that the prefix milli means a thousandth or thousandths, and kilo means thousand or thousands. Okay. So on the board, going from milliliters to kiloliters, we need to go from milliliters to liters to kiloliters. Wrote down two statements of equality. This would be equality, let's say it's called equality A and equality B. Where are we going to see those at? Right here and here. So I'm relating milliliters to liters in the first case, and then liters to kiloliters in the second case. Given 1,500 milliliters times 1 kiloliter is equal to 1,000 milliliters. The milliliters cancel, leaving me with liters. I don't want to end with liters, I want to end with kiloliters, so I need to relate liters and kiloliters with kiloliters in the numerator. Statement of equality written down. Units cancel across, leaving me with kiloliters. That's what I'm looking for. Do the math. Now I wrote it out this time just so you could see. If I put this over 1, 1,500 times 1 is 1,500. 1 times 1,000 is a million. Because we're dividing by a base 10, we can just simply slide the decimal place. How many places? 6 zeros. We're going to move it 6 places. We're going to make it smaller by 6. We're moving it to the left by 6. The implied decimal was here in 1,500. If you see 1,500, I move it to the left 6 places. 1, 2, 3, 4, 5, 6. I need to lead with a 0. 0.001500. In this case, we can drop the trailing zeros, and that's why the book has 0.0015 as the answer. On page 15, we start moving. Well, I'm going to stop saying start moving because this is the whole book. If you haven't gotten that, is just keep pushing forward. Covering concept, taking that concept and applying it in a slightly different way. We went from conversion factors, one of them with a direct relationship, then we went to a two-factor or indirect relationship. We started before with one factor in the same units system. We spent time now with conversion factors to take us to the other unit system. Now, on page 15, we start getting into this idea of derived units. And I mentioned already in class in the first couple of days that later on when we do math, we're going to end up with some pretty funky looking units. Some things you're going to look at and go, what does that even mean? I've never seen something like that before. And frankly, each problem has its own derived units because these things are kind of concepts. They're not things that we're used to seeing and measuring. They're things that are kind of in our mind as a concept. That's one of the difficulties that you'll have in chemistry. Some of you, not all of you, but as you struggle to get chemistry, one of the things you need to recognize that you're doing is you're stretching your mind to start to understand concepts which are a little bit beyond the obvious. They're more ideas than they are reality in your hand. Okay, so it's kind of the philosophy of chemistry at times. So there are going to be times when you sit there and go, I don't even know what that means. Okay, I get it. That's part of the struggle. That's part of, okay, but I'm okay with not knowing that thing. It's like in theology, you know. But Pastor Baker, or Mr. Baker, how can it be that I have free will and God is sovereign over all my choices? How can that be? I still wrestle with that. I can believe both to be simultaneously true at the same time and not be able to work them out perfectly to explain them to you so that it makes perfect sense to you. Okay? I can explain both. I can understand both those concepts. And I've got to struggle to say, but they can both be simultaneously true at the same exact time. That seems like a contradiction, but it's not in the mind of God. You say, well, that doesn't happen anywhere else. Well, yes, it does. For example, if you were taking physics, we'd ask the question, is light a particle or a wave? And the answer is yes. If you set up an experiment to prove that light is a particle, you will prove that it's a particle. But if you set up an experiment to prove that light is a wave, you will prove that it's a wave. It's a duality. It's both simultaneously at the same time, but science can't figure out how it can be both at the same time, but it is. Okay? So when we get into this area of derived units, this may be the first time when you start thinking about something which I don't even know what that is, but let's just keep on doing the process. Because if I keep doing the process correctly, I will ultimately get to where I need to be. Talking about derived units, and what you've picked up so far as we've done this math is that you need to treat both the coefficients and the units mathematically, right? Maybe up here, as I've said, well, we've got milliliters times liters over milliliters. Well, liters cancels liters, or milliliters cancels milliliters. I'm talking like that. You're going, okay, but I'm not used to seeing units like that. I'm used to seeing 3/4 times 8/7 equals something, right? And you're going, okay, well, 4 goes into 4 once, and 4 goes into 8 twice, and 2 times 3 is 6 divided by 7. Okay, I feel comfortable with that. But now in chemistry, we've added things like 3 inches and inches to feet, and now we're going, okay, but now you've added information. I need to do something with it. How do I handle the other information that's here now? I go, well, inches cancel inches, just like 4 reduces 8. That cancels that. Feet's left over, so my answer must be in feet. In derived units, when I was setting up the problems a moment ago, and I used those process arrows, and I said, we're going to go from milliliters to liters to kiloliters, many of you were fine with that. Okay, this is where we're going to move. We're going to move from these units to those units to these units. And then when you noted whenever we did the math that I had units and I carried the units forward too. Now, The units in the math problems we're going to do in chemistry, the units are handled separately but identically to the way the coefficients are handled. You'll see on page 15 they talk about adding and subtracting and multiplying and dividing. Let's say, for example, that they use in the book, let's use the 3x and 4y. If I said 3x plus 4x, combining like terms, what would my answer be? 7x. If I said that rather than x, that I was actually, x is a replacement for inches. Seven inches. If I have 3x plus 4y equals, what is that? I can't reduce it anymore, right? It's 3x plus 4y. It's an identity. It doesn't reduce anymore. So if I were to go back in and replace inches for x, but this might be 4 feet equals, see, I can't do the math any longer because my units aren't the same. So whenever you're adding or subtracting, the units have to be the same, meaning I've got to add 3 inches plus 4 inches equals 7 inches. I can't say 3 inches plus 4 feet equals 7 inches plus feet. Okay? When you're adding or subtracting, the units have to be the same. What makes it interesting in math is that's not the case when you multiply or divide. Again, hopefully you know that you can only add or subtract like terms. You can only add or subtract the same units. I can't take a liter and add a foot to it and get a liter plus foot. There's no such unit as a liter plus foot. However, if I were to multiply them together, let me just use what I just said. 3 liters plus 2 meters does not equal 5 units of liters plus meters. That's not true. You can't do that. However, for multiplication, if I had 3 liters times 2 meters, what do you think my answer is going to be? For multiplication and division, let's first of all do the coefficients. The coefficients are 3 times 2. 3 times 2 is 6. For multiplication and division, you do the same operation to the units. So I've got liters times meters. And my units here are going to be liter meters. What is a liter meter? It's a concept, right? There's probably going to be another step where we're going to eliminate liters and end up with meters, or eliminate meters and end up with liters. It's a concept. This is a derived unit of liter meters.